TechTalks Education, and let us look at the calculation of mass of a substance given its number of moles, because we had just looked at the calculation of number of moles of a substance given its mass. So let's look at this. Calculation of moles of, or let's change to mass, calculation of masses of substances in their given number of moles. So let us look at this question here. Calculate the mass of each of the following substances in their given number of moles. So let us look at this. The first one, let us see if I have 0.02 moles of potassium hydroxide. Given that potassium has a relative atomic mass of 39, oxygen with 16, and hydrogen with 1. So let us look at, in this case, the mass of potassium hydroxide in this number of moles. Yesterday we saw that, or last time we saw that, if you are converting mass to moles, you are supposed to first get the molar mass of that substance. And in this case, if we are converting moles to mass, that is, if we are looking for the mass of a substance in a given number of moles, likewise you are supposed to firstly get the molar mass of that particular substance. So for this one here, we are going to start with the molar mass of this compound called potassium hydroxide. We are supposed to write the correct chemical formula of potassium hydroxide. So potassium hydroxide. Potassium has got a valency of 1, and the hydroxide radical also has a valency of 1, and this therefore the formula of potassium hydroxide. So in potassium hydroxide we have one atom of each of the elements, that's going to be 39 potassium plus 16, that is oxygen, plus 1, that is hydrogen, and this one is 39 plus 16 is 55 plus 1 is 56 grams. That is the mass of 1 mole of potassium hydroxide. Remember, we are looking for mass, and therefore mass goes to the right hand side, and we start with moles. And in this case, we begin with the molar mass. The molar mass means that 1 mole of this compound, potassium hydroxide, weighs, see the word I'm using here, it weighs, it doesn't just contain, but that is the mass of 1 mole. So it weighs 56 grams. And then what of the 0.02 mole of potassium hydroxide? It weighs, we cross multiply 56 times 0.02 and we divide by 1. The unit is grams. Let us get the mass of potassium hydroxide in 0.02 moles of potassium hydroxide. So it is 15 times 0.02 divided by 1, and in this case I have 1.12 grams, and this is the mass of potassium hydroxide in 0.02 mole. of potassium hydroxide. Good. Let us look at another one. Supposing I have 0.25 mole of lead 2 nitrate. Given that lead has got a relative atomic mass of 207, nitrogen with 14, oxygen with 16. Let us get the mass of lead to nitrate in 0.25 mole of lead to nitrate. So what do we get? What do we start with? We are starting with the molar mass of lead to nitrate. So lead has a valency of 2 and the nitrate radical has a valency of 1. So that 2 will go and we shall put the whole of nitrate in a bracket, the nitrate radical, and the 2, which is the valency of lead, will come here. Let us get the mass of 1 mole of lead to nitrate. That's the molar mass of lead to nitrate. It is 207 plus 2 atoms of sodium, which is, of nitrogen, which is 14 times 2, plus oxygen is 16 times 3 times 2. So this one is 207 plus 28 plus 16 times 3 is 48 times 2 is 96. So this one gives us a total of 331 grams. That is the mass of 1 mole. So we are looking for the mass in 0.25 mole, and what do we start with? We start with mole. And from here, that 1 mole of lead 2 nitrate weighs 331 grams. Mass on the right hand side, because we are looking for mass in 0.25 moles. Then what of the 0.25 mole of lead 2 nitrate? So it weighs, and we cross multiply 331 times 0.25 over 1 gram. So let us get it using our calculator. 331 times 0.25, and I have got here 82.75 grams. So that is the mass of lead to nitrate in 0.25 mole of lead to nitrate. So let us look at another example here. Please, you must follow the steps carefully because every single step matters a lot, and your work should be clearly shown. And we use first principle, as we can see. We are not using arrows, we are not using dashes, we are not using lines, but we are using a set of words that forms a meaningful sentence. That's what we call working from first principle. So let us see the next one here. 2.5 mole of ammonium carbonate. Ammonium carbonate has got nitrogen being 14, hydrogen is 1, carbon being 12, and then oxygen being 16. So those are the relative atomic masses of the elements found in ammonium nitrate. So we are going to start by getting the molar mass of ammonium nitrate using the correct formula of ammonium nitrate. So that means a candidate must be able to know, you are supposed to know how to write the correct chemical formula using the valencies of the elements or the radicals in that compound. So we are starting with the molar mass of ammonium carbonate. So in ammonium carbonate, we have got the ammonium radical NH4, and we have got the carbonate radical. The valency of ammonium is 1. The valency of carbonate is 2. So that 2 has to come here. So we bracket ammonium and then put the 2 outside here. That's the formula of ammonium carbonate. So let us get its molar mass. It's going to be, there are 2 atoms of nitrogen, which is 14 times 2, plus hydrogen is 1 times this 4 times these 2 here, plus we go to carbon 1 atom, that's 12, plus oxygen, we have got 3 atoms, that is 16 times 3. Let's get this. This one gives us 28 plus 8, 16 times 3, then we have 12 here, plus 48. So 48 plus 12 is 60, 68, 96, 116. Let's prove that. 28 plus 8 plus 12 plus 48. It is exactly 96. 68, we have got 76, 96. So that is it, the molar mass of ammonium carbonate. So let us go ahead and we get the mass of ammonium carbonate in the 2.5 moles. And since we are looking for mass that side, moles this side, and we start with 1 mole of ammonium carbonate weighs, so it weighs 96 grams. Then what of the 2.5 mole of ammonium carbonate? It weighs 96 times 2.5 over 1 gram. And let us see our answer. 96 times 2.5. And we have 240 grams. So that is the mass of ammonium nitrate in the 2.5 moles of ammonium carbonate, So that is how we convert moles to mass. That is, if we have been given moles, how to get the masses. So don't forget this, that if you are looking for moles from given masses, you have to firstly work out the molar mass of that compound. And if you are looking for mass from some given number of moles of a compound or compounds, you need to also firstly work out the molar mass, then you come to your argument. So that is Step Talks Education. Thank you for watching.